Alright, in this video we will graph and analyze this rational function right here. Well, the first thing we need to do is factor the numerator and the denominator. Now, I'm looking at the numerator. It has 4 terms, and it looks like grouping is going to be possible. At a glance, I know that grouping is going to be possible because when I look at these leading coefficients, I've got -2 and I've got 1. That makes -2. Now, when I look at the second pair of terms, I've got -4 and I've got 2. If I divide, that also makes -2. Alright, if you divide the leading coefficients for each pair and you get the same number, that's how you know grouping is going to work. So let's go ahead and factor this by grouping. The common factor for the first pair is x squared. So if I bring out my x squared, then that's going to leave behind x minus 2. Now the common factor on the second pair is 2. And that's going to leave behind x minus 2 as well. Now x minus 2 itself is a common factor. So I'm going to take that x minus 2, that common x minus 2, and put it in the front. That's going to leave behind x squared plus 2. Okay, we just took the x minus 2's and we put that out front. So we just factored the numerator. Now we need to factor the denominator. Now 2x squared can only factor as x times 2x. 2 can only factor as 2 times 1. Or it might be 1 here and 2 here. We'll see. Now we know that inner plus outer equals middle. Inner, I have 4x. Outer, I have 1x. I'm trying to get a middle of -3x. I can get -3 if I have -4 and +1. So that means negative here and positive here. That does make -2 because -2 times 1 is -2. So that's how you factor the denominator. Now, we're looking to see if anything is going to cancel out. And I see that we have x minus 2 in the top and we have x minus 2 in the bottom. So that's going to cancel out. When something cancels out, that's when you're going to have a hole. So because the x minus 2's canceled out, I know we're going to have a hole at 2 comma something. I got the 2 because I'm looking at the thing that canceled out and setting that equal to 0. So if I set x minus 2 equal to 0 and solve, that's going to give me x equals 2. That's where the 2 is coming from. I am going to need the y value of the hole. So to get that, I'm going to consider the fact that now that the x minus 2's are gone, the remaining function is x squared plus 2 over 2x plus 1. Okay, so this, I can use this to get my y value. Now I am going to use my calculator. Okay, so I've got x squared. Let's see if I can make this any bigger. So I've got x squared plus 2 over 2x plus 1. I'm going to leave this in Ask X mode. Now, I need the y value that goes with 2. Alright, so that is 6/5. All right, so that tells me that there will be a hole in this graph at the point 2, 6/5. So let's go ahead and write that down. Okay, 2, 6/5. All right, let's also graph that. Now, 6/5, what is that as a decimal? All right, that's 1.2. So keep that in mind, that this is 1.2. So for this hole, I'm going to plot the point 2, 1.2. Now this hole is an illegal value. It's an undefined point. So we're going to put it as an open circle at 2, 1.2. So that hole in the graph is going to be right about here. And again, we'll just plot that as an open circle. All right, well, now let's talk about the vertical asymptote for this function. We're going to get the vertical asymptote by setting the denominator equal to 0. And we are not going to go back to the original function. We're just going to use this version that we get after we've canceled out the hole. So we're setting 2x plus 1 equal to 0. Subtracting 1 from both sides, that's going to give us 2x equals -1. Dividing by 2 will give us x is equal to -1/2. So that is our vertical asymptote. Okay, so x is equal to -1/2. So let's go ahead and graph that as a dotted line. All right, let's talk about the horizontal asymptote of this problem. The horizontal asymptote depends on the degree of the numerator compared with the denominator. The degree of the numerator is 3, the degree of the denominator is 2. When the degree of the numerator is greater than the denominator, there is no horizontal asymptote. So under horizontal asymptote, we will just write none. But that leads right into slant asymptote. If the degree of the numerator is exactly 1 more than the denominator, then you're going to have a slant asymptote. So this is degree 3 and degree 2. The numerator is 1 more than the denominator, so there should be a slant asymptote. The way we find the slant asymptote is by doing division. So we need to take, actually, we're not going to go back to the original problem. We will pick up from here, the simplified version, and we will do division with this. Okay, let's see, I think I have space for it over here. So we're finding the slant asymptote. And we will find it by doing 2x plus 1 divided into x squared plus 2. So be careful though, so I'm going to have x squared, but I'm going to need a 0x because there's no x term, and then plus 2. Okay, so when you do long division like this, the first thing you do is divide. You do x squared divided by 2x. All right, this is pretty tough. This x is going to cancel out one of these x's, so that's going to leave x over 2, which is the same thing as 1/2 x. All right, so that is what we're going to have to put up here, is 1/2 x. Again, x over 2, you know there's an invisible 1 in front of the x, so that's where this 1/2 is coming from. Okay, so I have 1/2 x. Now I need to take this 1/2 x and multiply across. So 1/2 x times 2x. Half of 2 is 1, and x times x is x squared. So this will just be 1x squared, or x squared. 1/2 x times 1 is 1/2 x. Now we are going to subtract by changing the sign. So this will become minus and minus. All right, let me clean this up. So these cancel out, and here I will have negative 1/2 x plus 2. So now it's time to divide again. So I'm doing negative 1/2 x divided by 2x. All right, I'm doing this divided by this. All right, well, the x's are going to cancel out. So it's just a matter of what is negative 1/2 divided by 2. I know that this is going to be negative 1/4. But if you weren't sure, you could use your calculator. So you could do negative 1/2 divided by 2. That's going to be negative 1/4. Okay, so that's going to give me negative 1/4 up here. Now I could keep going and I could multiply, but I'm already at the constant. That means whatever comes next is just going to be the remainder. And I don't need the remainder for the slant asymptote. The slant asymptote is just going to be this part at the top. So y equals 1/2 x minus 1/4. That's my slant asymptote. All right, so now we need to graph this slant asymptote. Now this is y equals mx plus b. This negative 1/4 is my y-intercept, and this 1/2 is the slope. So I'm thinking up 1 over 2. But I'm going to start with the y-intercept of negative 1/4. All right, negative 1/4 is just a little bit below 0. So it's going to be like right here. So looking at the slope of 1/2, I'm going to go up 1 over 2 repeatedly. So from here, let me make this a little bit bigger. If I go up 1 over 2 over and over again, up 1 over 2, up 1 over 2, up 1 over 2, this is showing me where the slant asymptote is going to be. And if I go down 1 back 2, I can do it in the other direction. Okay, so this is where the slant asymptote is going to be. I'm going to go ahead and graph this properly. All right, so there's my slant asymptote. Now it's time to find the X-intercept. All right, now again going back to the simplified version of the problem, we can find the X-intercepts by setting the numerator equal to 0. Okay, so I'm going to find my X-intercepts. Since we can get the X-intercept by setting the numerator equal to 0, I'm going to be setting x squared plus 2 equal to 0. Now if I subtract 2 from both sides, that gives me x squared equals negative 2. However, if I take the square root of both sides, don't forget your plus or minus, notice that you have a negative under this radical. That means we're going to have an imaginary number. So this is plus or minus I radical 2. You can't have imaginary x-intercepts. So because we're getting imaginary numbers, that means there are no x-intercepts. Oops. So we're just going to wind up writing none for x-intercepts. All right, now for the y-intercept, I think we still have this in our calculator. Yeah, for the y-intercept, we can just use the calculator, or look, let me show you how you would do it by hand first. For the y-intercept, all you're doing is you're substituting in 0 for x. You're evaluating the function at 0. So if I want to find the y-intercept, I let x be 0. I put in 0 for x. Okay, looking at this simplified version of the function, if I put in 0 for all the x's, that would be 0 squared plus 2 over 2 times 0 plus 1. All right, now the zeros are going to go away. So the 0x squared is just the 0 squared is just 0, so that's gone. 2 times 0 is 0, so that's gone. So that's just 2 over 1, which is 2, which means my y-intercept is going to be 0, 2. All right, now if you were uncomfortable with just putting in 0 for the x's, which if you're comfortable with it, you can just look at it and immediately see the y-intercept even faster than you could use a calculator. But if you do need a calculator, you could ask x. And we want to know the value at 0, and there you see it's 0, 2. So that will be my y-intercept, 0, 2. And let's go ahead and plot that point. Okay, so 0, 2, the y-intercept is going to be right about here. All right, it's that time in the program where we plot a bunch of points on the graph, and that shows us how to draw the curves. So when you want to pick which values you're going to use, you focus on the vertical asymptote. All right, that's the key. So we have one vertical asymptote, and it is here at -1/2. Remember, we found that vertical asymptote. It's here in green, and we found x equals -1/2. Now let's use that vertical asymptote to figure out which values we want to pick. All right, so if I take this vertical asymptote and put it on a number line. All right, so I have -1/2. Now, imagine that I put some whole numbers around that. So if I want to go to the left and if I want to go to the right. To the left of -1/2 would be -1. To the right would be 0. And what if I kept going? Then this would be -2. And this would be 1. And then I'd have -3. And then I would have 2. I'm looking to see how many values we have on this chart. We have 1, 2, 3, 4, 5, 6, 7, 8. So I'm just going to keep going till I get 8 values. So far I have 6. So I'm going to go one more time. Okay, if I went out again, I would have -4. And if I went out again, I would have 3. So these are the 8 values I'm going to use. -4 to 3. All right, so -4, -3, -2, -1, 0, 1, 2, and 3. Now I just need the y values to go with these x values. And for that, I'm going to use my calculator. All right, table feature. I'm not going to put the original function in. I am going to use the simplified version that we got. If I could just find it. All right, here it is in yellow. X squared plus 2 over 2x plus 1. All right. Now, normally I would do ask mode, but none of these are decimals. Normally, I would have decimals because I would start, usually the vertical asymptote is a whole number, and then I wind up doing decimals on either side. But in this case, the vertical asymptote was already a decimal, so I did whole numbers on either side. So it wouldn't really make sense to do ask mode this time. I'm going to start at -4, all right, because that's where my list begins. And I'm just going to do auto. It's been a while since I've done auto. Okay, so at -4, I've got -2.6. I wonder why this is not writing. All right, technical difficulties. All right, so here I filled in the 3 y values so far. I'm just going to keep going and fill in the rest. All right, so these are the values that I pulled off my calculator. Now I'm just going to plot all of these points up here on my graph. And here's what it looks like once I plotted those points. And so now I'm just going to draw the curve passing through all of these points. And I know it's got to approach the asymptotes on both sides, so it's going to be something like this. And similarly here, it's going to go through. Now I'm going to be careful to jump over that hole as I go. All right, so your graph should be looking something like that. All right, now we're ready to answer some questions, like the domain. All right, so this graph, it has a vertical asymptote. So the graph does not touch this vertical asymptote, which is at -1/2. So the domain is the x values of a graph. So this lower branch down here, if I look at the x-axis, it goes from here to here. That's -∞ to -1/2. So that's the first part of my domain. It's -∞ to -1/2. And then it's going to pick up from there and go from -1/2 to +∞. All right, because now I'm looking at this branch of the graph, but if I stare at the x-axis, it goes from here to here, -1/2 to infinity. There we go. All right, how about the range? All right, the range is a little tougher, and let's see, I'm going to have to remember what these points are. So it looks like this point here is at the top of the hill, and this point here is at the bottom of the valley. So just be very careful. There's a gap between these if I look from bottom to top. So the range is the y values. So I'm going to trace this on the y-axis, and I'm going to go from bottom to top. So looking at this branch of the graph right here, if I shadow it on the y-axis, it goes from here to here, all right, because that's how high it reaches. So that's -∞ to -2. All right, so that's the first part of my range, will be -∞ to -2. Now, I made a small mistake there by putting round parentheses. There should be a bracket on that -2 this time, because there's no asymptote here. this point -2 comma -2 is on the graph. It's right here. All right, so it is to be included in the range. Okay, so that's it for this branch. Now, then there's a gap, and it picks up again with this other branch. Now, if I shadow this part on the y-axis for the range, it goes from here up. All right, so that is from 1 to infinity on the y-axis. From here up, 1 to infinity. And again, it'll be a bracket. Okay, now let's talk about intervals of increasing and decreasing. Okay, so as I go from left to right across the page, this graph goes up and down, and then it goes down and up. So everywhere it's going up is an increasing interval. So it's going up from here to here. Okay, but these increasing and decreasing intervals, we're only recording the x values. We're saying from where to where is the graph increasing. You know, over what x values are the y values increasing. So if I shadow this portion of the graph on the x-axis, it goes from here to here. That's -infinity to -2. Okay, so that is my first increasing interval. Will be from -infinity to -2. All right, what happens then? Let's see, can I erase this? Oh man, I was afraid of that. Okay, that's not so bad. Now, after that, the graph starts decreasing. And the graph decreases from here to here. Now again, I'm only going to put this on the x-axis though. And there's a vertical asymptote. It stops here at -1/2. So the x values go from here to here. It's a tiny little portion of the x-axis where this is decreasing. And that is from -2 to -1/2. All right, from -2 until the asymptote where it stops. So that was decreasing. Okay. Then the graph jumps up here, and it is again decreasing for this portion of the graph. Now on the x-axis, again, that is a tiny little part of the graph where it's decreasing from here to here. That is from the asymptote to 1. All right, so that's -1/2 to 1. That's where the function is decreasing, -1/2 to 1. Okay, all right, and then the graph starts increasing again from here to here. On the x-axis, if I shadow it on the x-axis, that goes from here to here. That is from 1 to infinity. That's where the graph is going uphill again. All right, so another increasing interval will be from 1 to infinity. All right, let's talk about the end behavior. All right, as x approaches -infinity, that means on the far left, what is the graph doing? Okay, now be careful. When we're talking about end behavior, it doesn't matter what's happening here in the middle. All that matters is what's happening on the far left and then the far right. So first, we're talking about the far left over here. So as we go to the left, this function is falling. It's going down. So as x approaches negative infinity, the function approaches negative infinity. All right, it does not matter what's happening in the middle. On the far right, so as x approaches positive infinity, the function on the end here is rising. So as we go to the right towards positive infinity, the function is rising, approaching positive infinity. All right, so that is it for problem number 1.